Oh, hello. I didn't see you come in. And welcome to our online classroom here in BET 160, also known as Introduction to Geographic Information Systems, offered at Eastern West Virginia Community and Technical College. First off, I want to thank you for signing up for the course and welcome you either if you are a new student to the college or the program, or a returning one. You are about to embark on a wonderful journey of discovery, all from the comforts of this online classroom. Allow me to introduce myself. My name is Nathan Van Vranken, and I will be your instructor and guide for the course. I serve as the full-time science faculty here at the college, but also the coordinator of the Biological Environmental Technology program, where we want to be able to utilize technology to be able to answer questions related to the natural sciences. And these questions are scientific events that we can study, also known as phenomena. My academic training is actually relevant to this course because my background is in that of paleontology, but my research deals with utilizing the very techniques that you are going to be utilizing in this course to learn about the world around you and the spatial components. Now, before we begin the rest of this module welcome, I'd like for you to take a look at your Eastern email. And within it, there will be some very important information, including your course syllabi, which will explain all the course policies, learning outcomes, but also a calendar of when assignments are to be completed by. This module is extremely important because it lays the foundational groundwork for everything you'll be doing throughout the rest of the course. Before we jump into the more advanced tools and analysis, we need to build a solid understanding of really what GIS is and how spatial data works and the location being represented on Earth. Think of this video, this module welcome, as your roadmap for the topics that we are going to encounter in the coming weeks. GIS stands for Geographic Information Systems, but it's much more than just a piece of software. GIS is a complete system that combines hardware, software, data, people like users, like you and me, and the methods to help us understand the world using locations. What makes GIS unique is that every piece of information is tied to a very specific place on Earth. Instead of looking at data in isolation, we want to allow that data to connect information to where it occurs and explore patterns and relationships that would otherwise be difficult to see in the natural world around us. At its core, GIS helps us answer location-based questions. We can ask where things are located. Why are they even located there? How they relate to other spatial features nearby, and what would happen if, say, conditions change. For an example, GIS can help us understand why certain neighborhoods are more vulnerable to flooding. How far have people traveled to reach hospitals and medical attention? Or how has land been changed over time and space? And by linking data to geography, Using GIS, you can transform raw information into a meaningful, insight-driven context that will help you answer the phenomena. If you think about it, GIS is critically important because nearly everything we study, manage, or interact with has to happen somewhere in some place. You'll come to find that location plays a very critical role in understanding real-world problems, and GIS gives us the tools to analyze those problems on a spatial level. By organizing large amounts of data and being able to display it visually on maps and communicate it, GIS allows patterns, trends to emerge that might not be otherwise noticed. For an example, in environmental management, GIS is used to monitor things like deforestation, track wildlife risk, even analyzing climate change impacts, and manage water resources. Topics that are very important here in our Appalachian region. Those that might have a urban and regional planning interest. GIS helps planners design transportation networks, analyze population growth, and determine the appropriate use of land and their resources. What if you have a medical background or an interest in it? Did you know that GIS can help you answer very important questions in that world? For an example, public health professionals use GIS to track diseases, identify areas with limited access to healthcare, and even plan efficient emergency responses. In my field of vertebrate paleontology, I actually use GIS to spatially understand different fossil localities in the relation to the geology and reconstructed paleo environments and the plants and animals that may have lived in that area over time and space. Really, when you think about it, all the different fields can use some degree of GIS because GIS supports informed decision-making processes by showing not just what is happening, but where and why is it happening in real time. And that's going to be something we are going to cover in this course. ArcGIS Pro is a primary software platform you'll be using in this course. It's a professional-grade GIS application used by organizations and researchers around the world. While it may seem like a complex program at first, our first module here is designed to help you become more comfortable with navigating the interface and working with basic GIS tools. This program is provided for you on behalf of the Biological Environmental Technology program here at Eastern, but it was developed by Esri. In ArcGIS Pro, you'll learn how to open and manage GIS projects, explore maps, and work with data layers. The map view is really where the spatial data is going to be displayed, allowing you to zoom, pan, and examine geographic features. There's also going to be a contents page that shows all of the layers in your map and lets you control their visibility and order. The catalog pane also helps you organize and access your data, while toolboxes contain the analysis tools you'll use later in this course. By the end of our first module, ArcGIS Pro should feel approachable and intuitive rather than overwhelming. After completing the various exercises and tutorials found in our first module. One of the most important topics in this module is understanding how location is being represented on Earth. Because Earth is round and maps are flat, representing geographic information accurately requires careful systems and conventions. The module will be able to introduce you to the concepts that make accurate mapping possible in the procedures that you'll need to be able to do that in a efficient way. But you'll also be able to study maps and how to simplify reality for specific purposes, like communication. You'll learn about scale and how it describes the relationship between distances on a map and distances in the real world. Large-scale maps show smaller areas with more detail, while small-scale maps show larger areas with much less detail. And you'll also explore what a coordinate system actually is, because it provides a numerical framework for identifying precise locations using latitude and longitude, or projected systems like UTM. In addition, you're also going to learn about datums. And datums are important because they define the size and shape of the Earth used in measurements and map projections, which transforms the Earth's curved surface into a flat surface. Every projection involves trade-offs, and we'll be able to explore these trade-offs. And these can be whether in shape, area, distance, or direction. And being able to share with you these concepts early on in the class is essential because incorrect coordinate systems and projections can cause spatial data to misalign, leading to inaccurate analysis and conclusions, which could be vital for the area of interest you may be wanting to specialize in as part of your careers. You'll also be introduced to the types of geospatial data used in GIS. Spatial data represents real-world features and the phenomena that are associated with them, and generally falls within two main categories. We have vectors and rasters. Vector data is used to represent discrete features such as cities, roads, and boundaries, utilizing points, lines, and even what we call polygons. Raster data is used to represent continuous surfaces like elevation, temperature, and satellite imagery, where values change gradually across time and space. And we'll continue to work on and improve our knowledge on rasters and vectors as we delve deeper into other modules, such as Module 2. But we do need to be able to work with them and explore and find out where to even find that data using GIS and the ArcPro software. Along with spatial data, though, GIS actually uses what we call an attribute table, where this spatial data can be, again, found that help build these vectors and rasters. The attribute table is used to store descriptive information about the features. Attribute tables allows you to view, sort, and analyze non-spatial data linked directly to geographic features, and is formatted much like a Microsoft Excel or Access spreadsheet. And using that in tandem with GIS allows you to analyze both where something is and what it is at the same time. And we'll be doing these analyses in various parts of the course, such as Module 2 and 4. By the end of this module, you're going to have a strong foundational understanding of what GIS is and how useful this software can be. You'll be able to explain and describe common applications across different aspects of social sciences and natural sciences. You will be able to be comfortable with navigating the layout of ArcGIS Pro and its interfaces. You'll be able to open projects, manage the layers, and explore maps in depth, and understand on how maps scale, units, and how they affect distance, and detail, and recognize basic spatial relationships found within geographic data. You'll be able to explain why coordinate systems, datum, and map projections are necessary and how they reflect the accuracy of the spatial data you'll come to work with. Finally, you'll be able to interpret maps, you find the attribute table, which will allow you to read and analyze the spatial data with more confidence. These skills form the foundation for all future GIS work in the course. To wrap things up, this module is about building your GIS mindset and thinking spatially, because we're going to be introduced to the tools, the concepts that geographers, GIS professionals utilize in their day-to-day lives. So I want you, as you work on this module, is to take your time with this material, revisit the concepts as needed, and focus on the understanding how GIS represents the world. Once these fundamentals are in place, everything else in the course will become much more manageable. And please keep in mind about the due dates found on the syllabus, as we want to focus more on the technique rather than the pacing. Thanks for watching my module welcome for Module 1, and I'll see you in the next module and throughout different parts of the course. Please reach out if you have any questions or need a little extra help on the tasks from week to week or need clarification. You can get a hold of me using the information found on the syllabus that has been emailed to your Eastern email, but also posted on Brightspace. The modalities you can reach out to me is through video chat, such as Zoom or Teams. You can send me an email or swing by my office in room 208, the science labs on the main campus in Moorfield. All right, let's get started to learn more about the world around us. And have an excellent day on planet Earth.